Hi, in the previous video we have seen how to implement depth-first search with the help of a stack data structure, and we can do it with the help of recursion. And by the way, the operating system is going to use stacks even if we use recursion, so it doesn't matter, but maybe using recursion is a bit better as far as I am concerned. So we have the root vertex, or I'm going to see that this is just a vertex. I'm going to print out this vertex plus some spacing, and I'm just checking, I'm going to iterate through its neighbors. So vertex.get adjacencies list. Of course, I have to check whether this v is not visited, so we haven't visited this node. Then I'm going to call this method recursively. And this is why it's important, because we have to use a stop condition whenever we use recursion, and that's why we have to check here whether we have visited that node or not, unless we keep calling the same function again and again, so it's going to be an infinite loop. So that's why it's important. Maybe I'm going to set it to visited, and I said we just set the predecessor, it's not important, but anyways, the vertex. Okay, so that's all about how that's all the implementation of the recursive depth-first search. I think it's much more robust and much simpler. So if I run this algorithm again, DFS vertex, it is the same, yes. Then ABDEC, the order is different than the other, because depth-first search we can go to the leftmost element and we go to the rightmost element. So this is how here we go to the right, or I don't know, because the A has two children, the B and the C, but we don't know whether it's a left children or a right children. We store it in a list. So we go to the, I think, left, so that's why this has to be the leftmost element. Then we add the neighbor D, so that's why it is going to be A, B, D. We go as deep to the tree-like structure as possible. So it's working the same, that's why it gives a different result, because we can traverse to the right and we can traverse to the left. But it's working fine because it's not a breadth-first search. A breadth-first search go from layer to layer. Here we go as deep as possible, and with this implementation of stack we go to the right, here we go to the left, whatever, it is a depth-first search. So that's how we implement depth-first search in a recursive manner. Thanks for watching.